Now, what is a variance? A variance is a very important concept in statistics because it tells us a little bit about how much data are spread out. And in this particular tutorial, I want to look at continuous data. So that would be for continuous data. What is a variance? And I want to say that different data formats, so count data or proportional data, they have different ways of calculating such a variance. And I think the best way to explain what variance is to use an example. So let's say I make some measurements. For example, I measure the length of mouse tails, let's say. So mouse tail length, that should be with the tail in here. I don't want to measure the whole mouse, and I measure that in centimeters. And I just catch 4 mice, and let's say I measure 8 centimeters, I measure 12 centimeters, and I've got 2 mice with long tails. They are 14 centimeters. And I now want to figure out what is the spread, what is the variance. So the first thing that I want to do is I want to calculate the average of the tail length. So let's calculate the average, and we have already discussed how we can do that. So the average is we add all the tails up and divide by the number of observations. So we've got 8 plus 12 plus 14 plus 14, and we divide this by the number of observations that we have. So in this case we have 1, 2, 3, 4 observations. So we've got 4 mice. And when we do that, 8 plus 12 is 20, 34, 48. So we've got 48 over 4. And that I can even do that without a calculator. That would give an average of 12 centimeter. So here the average indicates the measure of central tendency, and we talked about that. This is on average the length of a mouse tail. But we see that only 1 out of our 4 mices actually has exactly the average. So we have a spread in here, and we want to give an idea of how big this spread actually is. So what can we do? How can we visualize that in the first place? So let's say we've got, here is our average line, that's 12 centimeters. And we have a mouse with 8. So here that's 8 centimeters. That is below average. We have a mouse with 12 centimeters. That's bang on. And we have 2 mice with 14 centimeters each. So that is our spread. And what we can do now is we can say, okay, what we do is we just simply measure how far away on average the tails are from the average again. How far away are our measurements from the average? So let's write that down. How far away are, and I probably should say from the average, far away from the average are the data points away. So okay, so what we do is we just simply, and I indicate that with a different color. So we just simply say, okay, so the first one here, that would be 2 centimeters away. Sorry, that is 4 centimeters. That's 4 centimeters away. This one here, 12, that's not away from the average at all, that's bang on. And this one here would be 2 centimeters. And this one here is 2 centimeters. And I didn't draw it to scale. Apologies for that. So we have sort of 4 centimeters, 2 centimeters, and 2 centimeters. And here we've got, in a way, 0 centimeters for this one. So that would be 0 centimeters. Now, of course, we could add up all the averages. We can say this one here is, in a way, because it's below the average, is negative 4 centimeters. If we add them up, we see they are all 0. They add up to 0. So that's not very helpful. But what we can do is we can actually say, instead of adding them up, we just ignore the sign. So we take away this sign here. And the easiest way of taking away a sign is we take the square of the difference. So in the first place, what we would do is we would say we have 8 minus 12 centimeters, and we square that. For the second one, we have 12 centimeters minus 12 centimeters, and again we square that. And again, the next one, we have 14 centimeters minus 12, and we square that. And for the last one, we have, again, 14 minus 12, and we square that. And what you see is, this here is my data point that I measure. That's the first one for each one of them. And I'll take a different color. And this one here, this is my average. This is my average. Right, now let's see what I would get if I did that. So 8 take away 12, that is negative 4 squared, plus 12 take away 12, that is 0 squared, plus 14 take away 12, that is 2 squared, plus the same thing, 14 take away 12, that's again 2 squared. And actually, this has a name, this thing. This is the sum of squares. And actually, it should be the sum of the squares of the difference between the data and the average, but nobody says that because that's just a mouthful. This is also often abbreviated as sum of squares, SS. So let's calculate our sum of squares. So negative 4 squared is 16, plus 0 plus 2 to the power of 2, that is 4, plus 2 to the power of 4 is 4. So here the sum of squares would be 16 at 0, that's still 16, plus 4, that's 20, plus 4, that is 24. So 24, that's our sum of squares. And what is the variance now? Well, for the variance, we say, on average, how far away from the average are the data points located. And what you see is I just put in this average here compared to here. So what does that mean? Well, the variance is defined as the sum of squares that we just calculated divided by the number of observations. And if you look at it, this is pretty much what we have done here for the average calculation. We've done exactly the same. We added up the measurements here and divided by the number of observations. And here we do the same thing. We add up, but this time we don't add up the individual numbers. We add up the sum of squares and divide by the number of observations. So here we would get 24 divided by, and we had 4 observations. And if we do that, the variance would be 6. And of course we would need to find a unit for that. So the variance we had here, when we look at what would be the unit, we had 8 centimeters minus 12 centimeters, and we squared that. So that means we had 16, that's what we got here, but we've got centimeter squared. We need to square the centimeters as well. So that would be the unit here. That is the unit for the variance in this case. 16 centimeters squared. That's quite important that we have this notion of the unit, that this is actually a square number. And because people don't like that very much, they have introduced a different concept, which is the standard deviation. So the standard deviation. This is just simply because people don't want to work with units that are squared, because that's not the same unit that we had our measurements in. Remember, we had the measurements in centimeters. And the standard deviation just simply is defined as the square root of the variance. Now I'm going to have a separate video on standard deviations. I just want to give you the equation for the variance. So the equation for the variance, the general equation for the variance, would be, we take the sum, and when we discussed the average, we introduced the sum sign. We start to count at 1 and end at n of the data point, and we call that xi, minus the average, and I write it out like that, minus the average, and we divide the whole thing by n, and you've spotted what I've forgot to put in. Very important, we need to take the square of this difference, because otherwise we would just simply get 0. So the variance is given as the sum of the squares of the difference between each data point and the average, and then we divide by 4. And that's a really important equation, and I just want to highlight that. So this is a very important equation that we use for the variance. And again, we can also write this as the sum of the squares of the difference between the data point and the average divided by the number of observations, and that is also a very common way of writing the variance. So that was a quite a long video, but I hope you understand now what the variance of our measurements actually indicates. It tells us on average how far away are the individual measurements from the average, and in particular it tells us how far on average are the squares away from the average. And we can do a lot of work with these variances. Now I need to point out that this is really applicable to continuous data like we've got them here. The variance for, let's say, count data or a proportion are calculated in a different way, but we will discuss that in a later video. So I hope this makes sense, and thank you very much for watching.